Okay, here we are outside. You see I found a little pile of sand and rubble, and it's ideal to have little rocks and some grass or sticks or twigs or something and some sand you can play around with, or at least some ground that you can dig into. Nothing is really that important specifically, but you need a kind of a place you can kind of mess up a little bit and dig into. So first thing I'm gonna do is get my little lake or river, ocean here. And I'm gonna dig a little hole for it because it's got to go kind of below ground level. And these are the mountains behind it. Kind of a mountains over here. And if some of it goes down into the lake, that's okay, no problem. And then I got some grass. I'm gonna put the grass, I'm gonna plant the grass like trees or plants up here on the mountain. I'm gonna put some more just covering the earth over here, and maybe some rocks, some little rocks and mountainous things here. And then I got my water. Pour the water in the lake, and there's also some plants growing in the lake. Some fish in there too. You can have something representing the fish. And then I got my little person, my little humanoid here, standing on the mountain, or he could be standing in the water, or she could be looking over the side of the mountain over here. And so there it is. Now, so we have the hydrosphere here in the lake. It's the hydrosphere. The geosphere is the mountain, and then the biosphere is the grass and the plants and the trees, and of course the person. So all we're missing is the atmosphere, and of course the atmosphere is there, and you can only see the atmosphere when it's moving. So you can blow on it. You can just blow like that, or you can use the straw and blow. You can see what happens. So now the key is the interactions between the spheres. So you can already see that the mountain washes into the lake. So some of the rocks and the dirt are going into the lake, and that's good. It brings nutrients into the lake, and it forms the lake and shapes it. And the animals inside the lake are using the nutrients and the dirt that are on the bottom of the lake. So that's kind of a obvious interaction between the geosphere and the hydrosphere. And then the biosphere is interacting with the geosphere. It's actually growing out of the geosphere in the soil here. The plants, they need the nutrients from the earth, and then the earth is changed by the plants that are growing in it. So there's the interaction there. And then we have the atmosphere is blowing. It blows over and moves some of the geosphere into the hydrosphere, and then also it blows on the hydrosphere that makes waves, and the waves come up and affect the earth around the lake. So that's the hydrosphere and the geosphere. It makes erosion happen. Sometimes it rains. Sometimes the water in the atmosphere comes down on top of everything. So there's an interaction between the atmosphere and the hydrosphere and the geosphere and the biosphere. Rain is sort of mixing everything up. You get little landslides and avalanches all happening just because the water evaporated into the atmosphere, and then later it comes out of the atmosphere back down onto the surface of the earth. And then of course the human can mess up everything. He can pollute the lake, he can trash the mountain, he can tear down the mountain, dig up the mountain to get the minerals on the inside. The human is sort of the most powerful destructive force between all of the spheres. Okay? And maybe the kids will have even more ideas about how the different spheres interact. All right, here we are with the first demo. The demo comes directly from the standards that say support an argument that the gravitational force by the Earth on objects is directed downwards. Well, if I pick something up and I drop it, it falls down. That's the end of the demo. No, it's not the end of the demo, but come on. Everybody knows, everybody feels that from the moment they're born, that the gravitational force is pulling down. Things are pulling everything down. In fact, a non-scientist would say, of course, what are you talking about? Everybody knows that it's down. Everything, you drop something, it never goes up, it goes down. We don't need to talk about that. That's just the way it is. That is true. That's the way it is. That's reality. It's such an ever-present reality, we don't think about it. But the scientists would say, well, what's going on here? Because actually, not everything goes down. If you drop a helium balloon, it doesn't go down, it goes up. Or fire and smoke often go up. They don't go down. Hot air balloons go up. So there's some things that go up. So what's happening? Furthermore, down. What does it mean, down? You ever think about down? Here we have a globe, and here's California, Monterey County, Salinas, Alisal, right there on the map. And I have these little monitos that I made, and I can put them on the globe. So if you put, for example, me sitting right here in downtown Alisal, Salinas, Monterey, California, USA, there I am, and I drop something, and it goes down. But wait, my friend that I haven't met yet, over here, exactly on the opposite side of the Earth, directly opposite, right off the shore of Madagascar in the Indian Ocean. There's Madagascar. I don't know if you can see that. Madagascar, big old island. And then there's the Indian Ocean. So here's my friend that I've never met, out there fishing in a little boat off of Madagascar, and she drops her hook. Where does it go? It goes down. It goes down, falls into the bottom of the boat. Okay? So, no problem. She's just there. She picks it up again, keeps on fishing. But look, here she is, right in her boat here, right exactly on the opposite side of the Earth. Here's me over here, here she is over here, exactly the opposite side. So I drop my thing and it goes down. She drops her thing and it goes down. Down. They're exactly opposite directions, down and down. What's going on? Well, in between us is a thing known as the planet Earth. Okay? So the Earth is what's exerting that force. They recognize that. Isaac Newton, I think, had a big thing to say about that. That gravity is pulling. Doesn't just pull down. It pulls things together. It pulls me to the Earth and the Earth to me, and it's always pulling. You know, I jump up, and it pulls me back down. No problem. It doesn't have to touch me to pull. Right? If I want to move something across the table, I have to touch it. I have to push on that thing by touching it. Maybe I could blow on it. I could push on it with my breath and blow on it, but I can't move it without touching it. That would be crazy, right? Move it without touching it. But gravity can pull without touching Like no problem, does it every day, we're all used to that. Gravity's pulling it down without touching. That's called a force field. A force field, force across a distance. And it can go a big distance. In fact, the Earth and the Sun are pulling on each other with a gravitational force. One pulls on the other pulls on the one. And that's going across 150 million miles. The Earth is pulling on the moon's pulling on the Earth. That's why it's not escaping. That's why the moon doesn't fling off and go to outer space. It's because they're pulling on each other. That's the gravitational force. And it always attracts directly to the center. Okay, so now we're seeing that by saying down is not as specific as saying the center of gravity, center of mass of the two objects are pulling towards each other. Okay, that makes it more. That makes this explanation that my buddy from Madagascar is dropping something down and I'm dropping something down. They're going in the opposite directions, but they're both going towards the center of the Earth. Does that make sense? Okay. So, by the way, there's two more things about gravity. It always pulls. It never pushes. You'll never find gravity pushing. It always pulls. Now you say, why? I say, why? That's not really a question for science. You might be surprised to hear that, but because we like to ask, why? Why does that happen? Why? And then we use science to try to figure out why. But in the end, science explains what's happening by showing how it happens. How does that happen? How is the force calculated? How do you know how big the force is going to be and the direction of the force and when the force happens on what? That's all how. Why it happens, actually science doesn't have anything to say about that. There's four main forces. Gravity's one of them, and it always pulls, and it depends on two things. It depends on the masses of the two things that are pulling on each other and the distance between them. That's all it depends on. And it's always there, no matter what. Okay, we're talking two protons or two planets, or two galaxies. You always got that force of gravity, and you can calculate it and you know what it is. Why it is, that's not for science to figure out why. Okay, the other thing is, like I said, it depends on the mass. So it only works on things with mass, not photons, for example, not neutrinos. They don't have mass. But everything with a mass is pulled to everything else. Wait a minute. So does that mean I'm pulled to my friend? I mean, can you see people around you right now? Are you pulled to them? You feel pulled to your friend? No, you can't feel. And what about like these two things? Are they pulled to each other? I don't really see them being pulled, but they are being pulled. The problem is they're so small, the mass is so small that the force of gravity between these two things is too hard to see. You can't feel it, so small. You need something with a huge mass to get enough force so that you can feel the force of gravity. Like the biggest thing you can imagine, the biggest thing you ever touched, the planet Earth. That's big enough so that when you put your mass next to that mass, now you can feel the weight. You can feel the force of gravity. Okay, there's an experiment, a famous experiment where you get two giant lead balls and you hang them and you put the whole system in a delicate balance and then you let it go, and you can measure the force between those two balls. It's heavier than a bowling ball, and you can measure how far they're pulling towards each other and measure that mass. That's enough you can measure, but even that's such a small force, it's almost impossible to measure the force between two things here on Earth. You have to use the Earth or the moon or the sun, then you have a big force you can actually measure. All right? Okay, now here we have the star brightness demo. And this camera here will be from the point of view of the student, and Arturo will be the teacher. The first thing you do is you find somewhere to stick one. They got magnets on the back, and a basketball goal usually works
And so you stick one right on the goal, and then you've got the other one and make sure they're more or less the same, fresh batteries or whatever, sitting right beside each other. Okay, so then the first thing you do is you make 5 paces towards where the students will be standing. All right, 1, 2, 3, 4, 5. All right, so then you'll have a line there or something, and I'm gonna stand right there. So then I'm standing right here, and then Arturo, as the teacher, will go back over there and stand beside the lights. And all the students are standing here, and you say, compare the 2 lights. Do they look the same? Yes, they should say they look the same. Okay, so now Arturo's gonna turn around and he's gonna pace in the opposite direction, away, and he's gonna pace, 45 paces, so that that light will be 10 times as far away as this one. So this close light is going to be 5 paces away, and that light is going to be 50 paces away. 1, 2, 3, 4, 5, 6, 7, 8. 40, 41, 42, 43, 44, 45. Now he's going to turn around, and there's the star. Now you want all the students to move back and forth until they can see those 2 stars right beside each other, right like that. And remember that those 2 lights are the same brightness. So they're comparing them, the brightness, as they look at them. See, you can do it from like over here, but it's best if they each move by and they see the 2 lights right on top of each other almost. They can compare the brightness. Okay? So then, that's it. They just saw that difference in brightness, and then you gather them up and bring them back inside for the discussion.